Hello and welcome to One to Grow On, a show where we dig into questions about agriculture and try to understand how food production impacts us and our world. My name is Hallie Casey and I studied and currently work in agriculture.
And I'm Chris Casey, Hallie's dad. Each episode we pick an area of agriculture or food production that confuses a lot of people and try to get Hallie to explain it to us. And this week we are focusing on organics again!
Today is the environmental issue of organic agriculture.
Part 2. Organics number 2.
Yes.
Because organics are good for the environment, correct?
Well, that's what we're going to try and find out, isn't it?
I guess so. You tell me. It's,
Okay.
I guess, an assumption that I make, an assumption that people have.
Exactly. That's why I wanted to talk about it, was because this is something that people often associate with the certified organic label. And I want to kind of dig into that and see how accurate that may be.
Well, alrighty then. Let's hear it.
Okay, so quick recap if you haven't heard our last episode, which covered a lot of the intro stuff about what organic means, what it is, where it came from. Organic compared to not certified organic basically means that these are farms that by law have to do things like not use GMO seed, not use conventional pesticides, herbicides, and fertilizers. Usually they're asked to present a plan about how they're taking care of their ecosystem and their environment and building up their soil and stuff like that. This doesn't mean that farms that aren't certified can't do these things or don't do these things, but if you're certified organic, you have to follow these rules.
See episode Organics Part 1.
Okay, so you ready to dive in?
I'm ready.
Okay, first topic is biodiversity.
Dun 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 dun.
So organic agriculture has some benefits sometimes for biodiversity. Sometimes you'll have more contiguous habitats because if you're an organic farm, you'll have to leave things in fallow. Sometimes you have to leave buffer sections, which means that you have just basically wild land that's not cropped in between you and another farm. You'll oftentimes have cover crops, which means that over the year it's more contiguous as opposed to over kind of the landscape, if that makes sense. There's a lot of different things that oftentimes when we compare organic to conventional production, organic usually will have more contiguous habitat for pollinators, which is dope.
Which, if you want a more in-depth discussion of that, check out our beekeeping episode. But my recollection when I hear you talking about contiguous pollinator habitats is there's not a monoculture for the bees to get bored with, basically. They've got a lot of different food to choose from.
So sometimes that's true for organics. It's not necessarily always true. You can have a monoculture that's in organic production, but oftentimes you will have a break in that monoculture more regularly because you have to have these things like buffer zones. So even if you have one field that is completely tomatoes or something that's, certified organic tomatoes, if the next fields next to you aren't organic or for some other reason, if maybe you have some kind of industrial facility or a road, you might have to have a buffer zone, which does give bees and other pollinators something else to eat.
Got it.
This also gives things other than pollinators habitat and things to eat. So generally, biodiversity can increase what we call beneficial insects, which includes pollinators, but also includes things like ladybugs and praying mantises, spiders, things that can eat things that eat plants. So it's basically just building up a food chain of insects and other arthropods in your farm. So you're building a place for other insects that might benefit you economically to live, which is also generally seen as good.
You got pest predators.
Exactly.
All right. What else?
On the flip side of that, when we think about conventional farming, you often see broad spectrum pesticides, which can hurt. So not only is the ecosystem not necessarily the kind of place they like to live, there might be less diversity, there might be fewer plants year round. You also have pesticides that can hurt not only pests, but also beneficials. So from a biodiversity standpoint, that's not great if we're looking to increase overall life in the world, especially if you're looking at arthropods that might be endangered or we might really be needing and relying on, like, pollinators, for example.
So part of the organic certification is to use non-synthetic pesticides.
Yes.
But you're saying some of these can still be harmful to beneficial organisms?
No.
No.
Although that is generally true, but when we look at the organic pesticides, oftentimes they are not as hurtful, I guess, is not the right word, but you get what I'm meaning. Basically, I'm saying
they're not as effective against pests.
Often, not always true, but often that can be the case. What I was saying was, in addition to an organic system possibly having a better ecosystem for beneficials to live in, they're also not getting poisoned.
Okay.
Which is good for biodiversity, right?
Got it. Sorry, I guess my brain was jumping to other places, but you're saying that the beneficial organisms have a better place to live in and they're not getting poisoned.
Exactly.
Great. Okay. That makes me happy. That sounds great.
Yeah.
Go ladybugs.
Organic systems also typically have more kinds of worms and more worms more generally, which is great.
And listener, if you don't know by now, Hallie loves worms.
I love the worms. I love them so much. And when I was recently in an NRCS training where we were talking about soil health, and one of the evaluation factors we were given was like number of worms. So we got to go out into a field and just like sit and count worms. It was great.
Oh boy.
Basically, organic systems, more generally, these practices that are codified in law that organic farms have to follow are meant to encourage a more well-rounded ecosystem, right? That is basically what I'm generally saying.
And a more well-rounded ecosystem just means for a healthier farm, healthier planet. Maybe I'm extrapolating, but it sounds like a good thing.
No, it is. It is. Especially when you think about all of the land that we have in agricultural production. That's a lot. You know, if you're an insect and there is a farm between you and your food source, that's a long way to go. So having contiguous habitat, increasing worms more generally can lead to higher plant nutrition and greater soil fertility. There's a lot of different benefits to having a better ecosystem. But you can also, if you have a more well-balanced ecosystem with some of our beneficials, then you usually have lower pest incidence more generally because they're getting eaten and they're not able to grow to critical mass, basically.
Awesome.
Yes. So next stop on our organic environmental issue choo-choo train is fertilizer and runoff.
And you have a word here, eutrophication.
Yes, I put eutrophication in the show notes just for you, Dad.
All right, that's great. Will you please define it for me?
Do you want to define it for our audience?
No, because it's one of those words that I've heard before, and then I'm like, oh yeah, I know what it is.
Uh-huh.
And now I think about how to define it, and I'm like, wait, I don't actually know how to put that into words.
Okay, I got you. So eutrophication is the idea that nutrients will run off of usually a field, usually some kind of farm, into a body of surface water, and that large increase in available nutrients in that body of water will lead to an algal bloom.
Got it. Okay.
So algae is a thing that grows in water. It needs nutrients to grow, and it will basically just grow very, very fast. And this means that you have less sunlight getting into the body of water, which is bad for different reasons. It's usually taking up a lot of the dissolved oxygen that is actually in the water. So you'll have fish that are trying to breathe that, but the plants are breathing it. But the algae is breathing it, and so the fish don't have anything to breathe, and they suffocate and die. And you have there are other consequences of eutrophication. Those are some of them. Generally, it's bad.
Summary, fertilizer runoff is a bad thing.
Yes. You can also have fertilizer leaching into groundwater as well. Nitrogen in particular is very water soluble, and so it will move, whether that is off of the field into a river or lake or down through the soil into an aquifer or a well or something similar. So comparatively, this mineral fertilizer, you can use it in conventional systems. You can't use it in organic systems. So organic farmers have to get nutrition from somewhere. So often they will use manure, whether that's cow manure, chicken, sheep, horse, whatever it is. That's a very common source of nutrition for farmers who are organic certified.
So poop, cow poop. Everyone loves to use it. Why doesn't everyone just use it?
A kind of poop.
A kind of poop?
A kind of poop, yes. There are some benefits to this. It can build up soil more generally because you're adding carbon. There's a lot of carbon in manure that you don't get in mineral fertilizer because that mineral fertilizer is just going to be like NH4 and some other, closely related compounds. It's not necessarily going to have all of this lovely carbon that's going to sink back into our soil. That's going to be one benefit. However, because you have so much carbon in addition to the nitrogen, you'll usually have a lower yield relationship per pound of manure than per pound of fertilizer. I said usually, it's not usually, it's always. Like, if you're putting a pound of nitrogen fertilizer on, there's going to be a lot more nitrogen in it than if you put a pound of manure on, right? The manure is going to be majority carbon. And plants aren't taking up carbon through their roots. They're taking it in through their leaves. So it's not helping them really grow. They need that nitrogen. So you have to apply a lot more manure to a field than you would mineral fertilizer.
Oh, wow. I just thought everyone loved manure and it was the best thing ever. But I guess you need more than just that. Yeah.
I mean, there are a lot of benefits to manure. There are a lot of good things about it, but there are some challenges. You can only apply so much manure, and there's only so much nitrogen in a pound of manure.
Okay.
You also have to be getting that manure from somewhere, and a lot of times there is readily available manure that wouldn't otherwise be decomposing. If you're near a feedlot or something like that. But sometimes you see farmers that are, just taking it off of forage land where it could just be going back into the soil there. So there's some funny trade-offs with manure. Plant nutrition is something that we're still really thinking about, especially with organic and regenerative agriculture. Manure is one thing that people often turn to, but increasingly we're seeing that it's probably not the only answer, and things like fungi relationships are going to be a lot more involved in how we feed our plants going forward.
The more you know. What do mushrooms have to do with it?
Well, okay, so there are mushrooms that live in the ground that form networks, and they're called mycorrhizal, which basically is a word that means goes inside of the root. So there's like these little fungi who will like stick their little noses into a root, and they will pump things in and out. Certain mycorrhizal fungi can actually take N2 and turn it into something that is plant available, right? Plants cannot take up gaseous nitrogen, which is, often seen in N2. We see that a lot in our atmosphere. They can take up things like ammonia or nitrate. And so these fungi are able to take that N2 and turn it around and put it into a compound that plants can take up. That's what's called fixing nitrogen. So you're basically fixing it out of the nitrogen and sticking it into the soil and holding it there. So there's all these different relationships where fungi are able to open up nutrients that might already be there, but that plants aren't able to access.
That sounds bonkers and amazing.
It's very interesting. Very interesting. So this dovetails very nicely into stop number 3 on this choo-choo train, which is soil.
Okay, we already talked about soil. We spent a whole episode on it.
I know, but this is about how organic agriculture changes the soil in comparison to conventional farming.
Okay, I'm curious.
Okay, well, I love soil, so this is, in my opinion, possibly the most important topic that we're going to talk about in this episode.
Oh boy, let's get dirty.
Okay, so in 1987, there was a Nature article by this guy named John P. Reginald and a couple of other co-authors that talked a lot about soil and organic agriculture. And it was done by these guys who study a lot of different ways that organic agriculture impacts the farming system. They basically found that soil that was farmed organically had higher organic matter, which is good, thicker topsoil, which is very good, a couple of other things, but most specifically, lower erosion, which is very good. And then more recently, there have been some more science, and there was a paper published in 2018 that found that when looking at organic systems, lower tillage is really the key in lowering erosion. So there are generally things that haven't been associated to reduced tillage, like thicker topsoil and more organic matter, all pros. But this idea of reduced tillage is specifically linked to reduced erosion, which is very good. When we're thinking about sustainability long term, erosion is very key in agriculture. We often think of erosion in big movements like in the Dust Bowl here in the US. There have been other things throughout history, but here today in 2019, every farm loses topsoil every year, almost.
And I'm guessing if they lose it, they can't really get it back.
No. I think the number is like 100 years to regain 1 square inch of mineral soil,
Wow.
which is different from organic soil, but it's like a very long time frame. So if you're looking at losing 1/8 of an inch of topsoil every single year or 1/2 an inch of topsoil every single year, that's huge and very significant. So when we're thinking about erosion, I mean, this is something that's codified in the U.S. organic legislation. This is like farmers have to present a plan that talks about how they are going to conserve their soil and reduce erosion. But this isn't necessarily something that other farms aren't seeing. Like, this is a prerogative for all farmers, right? This is their long-term resource. If they lose their topsoil, they're not going to be able to farm anymore at all. So you're seeing increasingly, more than most of the other organic practices, reduced tillage, no tillage, minimal tillage in more conventional systems, because you're really seeing this tied with reduced soil erosion.
I say it's just good business sense.
Exactly, yeah. And so this is something that we see a lot in organic systems, but it's really not exclusive to organic systems. And this is true more generally. There's a term that we bandy about a lot called regenerative agriculture, which is kind of more of a philosophy. It's not necessarily a set of rules like organic is, where you really have to follow these rules and you have to be certified and you have to have paperwork every single day that shows, I am following these rules you're giving me. Regenerative is more general, and it's focused less on, what inputs are going in and more on what is coming out and what are these benefits that I'm bringing back to my farm and how is my productivity changing with these possibly more holistically considered or ecologically considered practices, if that makes sense.
Yeah. When I hear you talk about this stuff, it brings to mind our favorite sort of non-word, sustainability, which maybe this is sort of what people think they mean when they say the word, or at least part of it is.
Yeah, and I think that's partly how the term regenerative kind of came back into fashion as opposed to sustainable. Because, I mean, even when we think about it here in the US, sustainable isn't really enough. Like, we can't just sustain where we are at. We have to rebuild our soils because they have been degraded over time. Over the past 100, 200 years, they have been degrading. And so we really have to regenerate them. We have to, think critically about how we are handling our soils and how they're going to be able to continue to be productive into the next decades and centuries.
Okay.
So are you ready for our next stop in our environmental issue of organics?
Choo-choo. Carry on.
Fossil fuels.
I mean, they're organic compounds, right?
True. Okay, so just really quickly, pesticides, herbicides, fertilizers that are synthetically produced and used in conventional systems often have a very, very high footprint. And, in organic systems, sometimes you have to run the tractor more often because you're not, able to use herbicides, so you have to weed or something like that. But these pesticides, herbicides, fertilizers just have a really, really significant carbon footprint, and they have often a lot of fossil fuels associated with the production. I mean, we've talked on the podcast before about the amount of energy that goes into producing nitrogen fertilizer. It's really significant.
So just to be clear, it's the non-organic certified stuff that has the larger carbon footprint. But the stuff that you use for organic farming has a lower carbon footprint?
Well, it does have a carbon footprint, especially when we talk about things like manure. People often think of cattle and they often think of methane. There are carbon costs associated with all agriculture, and that is not going to change regardless of whether or not you're certified organic. But nitrogen fertilizer particularly is very, very intensive. There is a lot of energy that is required in creating mineral nitrogen fertilizer. That's just the facts.
So the point being that reducing the use of nitrogen fertilizer reduces a farm's carbon footprint.
So it's hard to say on a farm level, right? Because they might be running the tractor every single day, and
Right.
in which case it might not balance out. But on average, I think that is correct. There is science to kind of back that claim up.
Okay, I was just trying to make sure I understood why we were talking about fossil fuels.
No, for sure. And that dovetails nicely into our next stop, which is climate change. So fossil fuels is a part of climate change, but it is not the only part. So one of the biggest things that organic agriculture has seen in relation to climate change is a reduction in nitrous oxide emissions from soil. So, Dad, tell me about nitrous oxide.
Also known as NOx, I think. NOx and
really?
SOx. Yeah.
That's
well,
fun.
One of my professors talked about NOx and SOx, and it was nitrogen compounds and sulfur compounds being released into the atmosphere.
Oh, I didn't know that like chemicals got nicknames. That's nice.
Right. There's a lot more to it that I don't remember. But nitrous oxide is what the dentist gives you and makes you laugh. And I believe it's also considered a greenhouse gas.
It is, yes.
Maybe even more so than CO2.
I think the number that I was quoted was that N2O was 200 times more potent in warming the atmosphere than CO2.
Wow. That's a lot.
Very significant, yes. So we don't see as much N2O emissions from the planet, which is why we don't talk about it as much as CO2, but it is very significant when it does come off. And that is something that often leaves agricultural fields. I mean, we've been talking about nitrogen this whole episode. When you add nitrogen into a system, it is going to leave. Sometimes it leaves as N2, but sometimes it will attach itself to a little oxygen and float away in that form. So organic agriculture generally has lower nitrous oxide emissions, which is important when we talk about climate change and agriculture.
Indeed.
You often also have higher carbon sequestration because of kind of the soil building practices we talked about earlier.
You got to put the carbon in the corner.
What?
You got to sequester it from everyone else.
Yeah.
What is carbon sequestration? How do they sequester the carbon?
It's kind of what we were talking about earlier with manure, where you have something that's very carbon heavy, and if you put it on top of the soil, eventually it is going to incorporate itself into the soil. And so instead of turning into a gas and going into the atmosphere, it's just going to stay in the soil in carbon compounds.
Okay, cool.
Very cool. We talk about this a lot when we think about forests. Forests are a very good carbon sequesterer because trees are almost exclusively carbon.
Because of their lignin?
Partly yes. Partly
Yay.
yes. Congratulations, Dad. 2 episodes ago. You're holding on to it.
Thank you. I remembered a word. I remembered one of Hallie's knowledge nuggets. There we go.
Another thing that is kind of funny when we think about climate change in relation to agriculture is that these synthetic inputs, these herbicides, fertilizers, and pesticides in conventional agriculture, because they have so many fossil fuels associated with the production, they can often be tied to the petroleum market. And so farmers, as the climate continues to change and these prices become more and more volatile and continue to increase as oil stores deplete, those prices are going to become volatile and are going to rise. So if you have an organic system that doesn't rely on those, you'll see a lot more stable projected costs for farmers, which is kind of an economic benefit, but also related to climate change. Okay, really quickly. So the very last thing is animal agriculture. Basically, oftentimes people associate organic agriculture with environmental benefits, but animal agriculture in organics, we've actually seen that forage systems compared to feedlot systems, which would be non-organic, have higher energy use, higher land use, and higher methane output. So basically, your grass-fed beef, stuff like that, is going to have higher methane than corn-fed beef or something similar.
Oh, that's pretty much the exact opposite of what I would have predicted.
And yet. So I know that was a lot of information, a bit of a dump. Why don't we take a really quick break, and then we will get back into it.
Into the break.
Hey, Dad.
Hey, Hallie.
This is the second episode of our organic series.
It is. It's been a lot of fun.
It has been a lot of fun. And this is something that we would love to continue to do. We really enjoyed being able to take a deep dive into kind of a bigger topic. So if this is something that you're enjoying and you're finding interesting, you can head over to our Patreon and support us.
$1 per month would go a long way to helping us defray our cost. Patreon.com/onetogrowon. I know I've learned a lot. This has been a pretty enlightening series for me, and I may well be changing my buying habits by the time it's over.
Yeah, and I would like to quickly thank Lindsay, who is our number one, our star in the sky, our eternal light. Lindsay, thank you for your star fruit level patronship.
Thank you, Lindsay. You're amazing. And thank you to LD, who just updated their membership.
Thank you very much. All right, should we get back to the episode?
Back to the episode. All right, so we just learned a whole lot about the environmental implications of organic agriculture.
Yes. In summary, agriculture produces a lot of gases, and that's not going to stop even with organic agriculture. A lot of the research shows that organic overall will reduce greenhouse gases on a farm level, but there is little to no evidence that it can actually contribute to larger mitigation climate change effects. Like if organic farms doubled in number, it's not going to stop climate change.
So we're all going to die anyway.
I mean, who knows, right? I mean, we are all going to die. Will
That's
it be
true.
from the heat death of the universe or the heat death of our planet? Who knows? I don't.
But organic agriculture is not going to make a huge dent in that.
There is currently no scientific evidence to support that. No.
That makes me sad.
Yeah, well, I'm sorry. So some of the trade-offs when we think about organic. So first is land use. So organic agriculture has a lower yield than conventional agriculture.
That I did know.
Yeah. So when we think about, there is a limited amount of land on this planet, right? That is also a limited resource that we have. So with organics, you're getting less food for the same amount of land.
Okay.
So when we think about using limited resources, that's one column where organic agriculture generally loses. This might not always be the case. Some people have really advocated for including genetically modified crops in organic certification. And if that is the case, there may be a way to offset it through genetic modification or other breeding techniques. If there are other organic growing techniques that happen, if we learn maybe a lot more about fungus, virus, protozoa relationships in the soil and greatly increase the amount of nutrients available in the soil or something like that, if there's some other revolution in organic techniques, that might change. We might be able to grow more food in organic systems. As it is, there's not a ton of money in studying organics compared to conventional because there's not a lot of big corporations paying for that research. So it's something that's being studied, but we'll see. I mean, we're increasingly going to be needing more food, right? Populations are increasing. That is universally accepted. So when thinking about organics, that is a significant trade-off. If we're going to be producing less food per unit of land or even per unit of labor, we're gonna need a lot of food. So that is really something to think about. When we think about land use as well, I think that we kind of have to talk about meat because meat uses exponentially more land than like a vegetarian diet or something like that. So organic agriculture, if a lot more of the world ate a lot less meat, would be a lot more viable than it currently is today, if that makes sense.
A lot more of the world ate a lot less meat. Yes, that makes sense because, you have and this is an argument that I've heard for 30 years is, it's easier on the system if you're growing fields and fields of grain or fields and fields of whatever. You can feed it to people or you can feed it to animals, which go to feeding fewer people.
Yes. Yeah. We can talk about meat production in a whole different episode, but yeah, there is kind of an exponential loss of energy every time that something is processed, like an energy source is processed. So the sun is processed by plants and there is an exponential loss of energy there. Plants are processed by an animal and there is an exponential loss of energy there. So if an animal is processed by another animal as opposed to us being the animal that processes the plant, you just have less energy loss more generally. And similar with land use, you're able to eat a lot more of the food that's grown on the land. We don't really have time to get into all of the nitty gritty about animal agriculture and production, so let's talk about life cycle analysis.
What in the Sam Hill is that?
Life cycle analysis is this fascinating scientific tool where basically scientists try to look at everything that will go into an object, a process, a system, and how that might affect the environment. So when, sometimes you'll see articles about like this toothbrush is better for the environment than this toothbrush. And sometimes the tool that's used is like a life cycle analysis where you're able to look long term at like bamboo versus plastic and like how much land is being used for the bamboo and, are we irrigating the bamboo and how much water is being used and how much energy does it cost to pump the water to the bamboo versus like how much carbon are we using to process plastic toothbrushes or something like that. It's the idea of trying to consider every single thing that's going into something to understand how it's going to impact the whole environment. It's very complicated. It's very fascinating.
Wow. Yeah, that sounds very, very complicated.
So there was a life cycle analysis done of organic wheat. And what was found was that if organic wheat was shipped 420 kilometers further than conventionally grown wheat, the ecological benefits are null. It's like they're equal.
Just because of the trucks driving it.
Yeah, that added cost of like that carbon and all of that stuff is going to balance out whatever other ecological benefits that the organic growing system will have for that wheat.
Wow. There's no way to win.
I mean, there is a way to win. Maybe you live right next door to organic wheat and you can just mill your own crackers. It doesn't have to travel 420 miles.
That sounds like a lot of work, though.
I mean, yeah, it's a lot of work to mill up, wheat into a cracker or something like that. And I should also say that these results can vary drastically depending on like the soil carbon accumulation in an organic system versus a conventional system, or the nitrous oxide off-gassing from a field. If you have an organic system that's off-gassing a lot of nitrous oxide, it's going to be worse for the environment because nitrous oxide is really bad for the environment. That's not something we expect consumers to know, but when thinking more broadly about organic agriculture as a system, it's really important to think about the nuances of organics and agriculture more broadly. I'm going to keep talking about this throughout every single episode we talk about organics, but you can have farms that are ecologically beneficial that are not certified organic. You don't have to be certified organic to be ecologically beneficial. You don't have to be ecologically beneficial necessarily to be organically certified. We are talking about kind of broad, sweeping conclusions based very generally on a lot of data. And that's not necessarily how farms work. So it's kind of hard for us to say that, one is better than the other. This is what these big data are telling us. But, this is not going to be the gospel truth for every single organic producer, right?
So when someone comes up to me and says, should I eat organic? My response is, it's complicated.
Listen, we are only halfway through these 4 episodes, Dad.
Oh, man.
There was a very interesting study that I do want to talk about before we finish up.
Okay.
It actually took place in Beltsville, Maryland, and it took place over a long time. One of the things about organic agriculture is we don't always have long-term data, but this Maryland study that the USDA did looked over many, many years and compared an organic system to a conventional system nearby. And this is kind of what they found. They found that the organic farm had more fertile soil, used less fertilizer and fewer herbicides, used less energy, was more able to store carbon. They found that the conventional farms had higher yields. And the thing that was really interesting was that they found that the organic system was actually more profitable.
Oh, that is interesting. I mean, organics are much more expensive, but so much more goes into them. I wouldn't have necessarily expected that.
So organics are not always necessarily more expensive. You do sometimes see organics actually having a market price that's lower than conventional for different reasons. But yeah, this is something that is very interesting. And we talk a lot about in the soil health realm that I am a lot more familiar with than kind of the certified organic realm. But soil health is also considering a lot of ecological benefits, like when we were talking about earlier with having an ecosystem that's more balanced, having to use fewer pesticides because you just have fewer pests because they're being eaten because you're harboring all these praying mantises. that has economic benefits. And often what we see, at least from soil health, and I don't honestly know if this translates to organics, but you'll see a higher initial cost as farmers are trying to transition their system. Maybe they have to buy new implements. Maybe they have to buy and test out new systems or practices or inputs or different things. But then eventually you'll have much lower costs. And while your yields might go down, you're going to have lower costs so that gap between your yields and your costs is going to grow. So you're going to be making less money, but you're going to be spending a lot less money than you were originally. So you just are taking home more money, if that makes sense.
Yeah, it makes total sense. That's awesome.
Yeah. Again, I don't know really how that translates to organic. It makes sense to me that that general principle would apply if you were looking at an organic system that really focuses on the ecological benefits of organic farming, but not all organic systems do, especially if you're dealing with a really large-scale farm, like a Driscoll's or something like that. Driscoll's has thousands of acres in organic production, and it's kind of hard to have an ecological view if you have, several hundred acres of monocultured berries or something like that, These are general principles that are encouraged, but on a large scale, they can be difficult to implement and are often not implemented on a large scale. But that's kind of all I have for the ecological stuff. Generally, across the board, organics are generally better for the environment, but marginally so, and they're not going to change the world, is the conclusion for today.
Well, generally, we will see you, hear you, be in your ears again in 2 weeks,
where we will bring you more information about organic agriculture.
Quick preview. What's the broad topic? 3 words.
It's actually farmers and farm workers.
Oh,
yes.
That'll be very interesting. I can't wait. Thanks for listening to this episode of One to Grow On.
If you'd like to support the show, please rate and review us on iTunes and consider donating to our Patreon at patreon.com/onetogrowonpod.
If you'd like to connect with us, find us on Twitter, Instagram, and Facebook at One to Grow On Pod.
This show is hosted by me, Hallie Casey, and Chris Casey.
It's produced by Catherine RJ and Hallie Casey.
Our music is Something Elated by Broke for Free.
Be sure to check out the next episode in 2 weeks.
But until then, keep on growing.
Bye, everybody.